Salutations from the stars! 'Tis I, the eccentric Professor Copperstein. I'm here with Lesson 1 of Arduino. The introduction. So just in case you're someone who's never heard of Arduino before, or if you're new to engineering or any of this, or new to Arduino, allow me to introduce you to what Arduino is. Arduino is a programming language, and also the circuit board, that is basically used to talk to electronic circuits. Basically, it's how you can make circuitry that you can program it, you can make it do whatever you want. It's even be used for making robots. You can make AI out of it. So here is the Arduino circuit board. Well, actually one of many. There's more. Okay, this one here is called the Arduino Uno. It's standard type. You'll get this if you first started. Now here's some things you should know about the Arduino Uno. First and foremost, this long bar right here. This is called the Atmega 328P microcontroller. A microcontroller. Basically, it's got resistors, transistors. It's integrated circuit really. There's pins in there. Also, it's not removable. Don't take out, otherwise you'll never use it again. You'll damage the thing. So that's the here, and also here. You won't see it though. Those are the three hearts. Only use one at a time. The Arduino Uno is on a strict diet of 5 volts. You can also use 3.3. Not just 5. Yeah, 5 is more simple. Do not exceed the 5-volt limit, otherwise you'll fry the circuit board. So I'll teach you some things about this. So basically all you have to know is these are the hearts, and this is the brain, and these are the actuators. So these are the pins. There's 2 types. No, there's more than 2 really. Okay, these are the voltage pins here. Okay, let me just give a nice closer look at it. Okay, if we can focus. This webcam is very old, by the way. It's an old 2004. Why is it all blurry? Okay, you know what? I'll just do it like this. Okay, so first and foremost, these pins right here are the most important. These are the voltage pins. So you have here this one at the very end before there's like this gap where there's no pin, and then there's more pins here. This one's the starter one. The first one I want to talk to you about. This is called the voltage in. This is if you want to connect a battery pack to the Arduino. Now, what you can do is you can assemble your own battery pack. I recommend looking for either a battery that's specifically 5 volts, or you can even get like one of those Christmas light thingies, the ones that they have run on their own batteries. Just take out the lights and then just have your own, and then solder your wires on the positive and negative ends. That's that's if you're good with electronics and soldering. I'll probably have a video on that. So what you have to know is that the Arduino, I told you before that you have to have 5 volts. More than 5 volts can cause it to spark, to fry. You can damage the Arduino Uno this way. So next, the 2 ones after that, these are ground pins. There's another one over here. They're accompanied by like a white space right here. You can also see it on this side. It says GND, obviously meaning ground, and basically, well, you know it. If you know electronics, you know that it's where the negative side goes. That's where all the electrons go to when they complete the circuit and then go around. You know. And then next there's 5V and then 3.3V. those are the positive ends. These are the anodes. You get a wire here, and then you plug it into the voltage supply. It supplies, depending on which one you put it in, it de- it supplies an amount of volts to the circuit. So if you put it in the 5V, it supplies 5 volts, 3.3V, 3.3 volts. And then there's also reset, IO ref, and then one free one. Okay. Now next are the most are other important ones. This side. Okay, here we are. These are the digital pins, the ins and outs. You don't have to worry about pins 0 and 1, 2 through 13 are the ones you have to worry about. As you can see, there's another ground pin right here. And basically, these are the actuators. Or at least if you're gonna be either supplying, if you're gonna use these to supply voltage to the circuit, or if you're gonna, they are actuators, or they can be sensors if you have the Arduino, if you program them to be inputs. There's more on how to do that, and so that's what I'm gonna do in the video. Okay, so to power the Arduino, there's 3 options. You can have the option 1 that I listened earlier, where I have the V in, also known as the voltage in. Oh, I should also mention these. Now these pins are the analog pins. These are for if there's like digital is on and off, analog. Well, these are for analog sensors. They sense, they pick up any analog signals, and analog signals can be distributed through PWM. I'll tell you about that later. Okay, so option 2 is you can also, well, actually this should be option 1 because this here is actually a USB cable, no, USB port for the circuit board. This here, it's got here, you plug this end through here. That's my phone. And then the other end, yes, it's this one. It's standard, and I have nowhere to put it in because I have them both filled. Well, okay. Okay, so let's get started here. This here is the Arduino IDE. So basically, it's where you put all your code, and so as you can see, I named this sketch experiment Arduino 1.8. Yeah, this is the current version of Arduino. It's 1.8.12. So one thing you will have to be wary about is the sketchbook. It's the folder in your file explorer where you will find, where to find all your sketches. You can find it. You can control comma, and then in there you can. That's where you open your preferences, and you can change the location of your sketchbook. You can name it. All right, so let's get started. Here, all Arduino sketches are composed of 2 parts, 2 main bits of code here: the setup and the loop. Now, yeah, me typing. So first and foremost, you want to start it with the word void. Excuse me. Now the word void is the reason we have void here is that it's actually a declaration of a variable. There's different types here. As you can see, there's int. There's even, what else is there? Long. There's short. In fact, you can even put unsigned, and there's also signed. My computer makes that noise. Okay, and so void is the variable declaration if your variable has no numeric value. So first and setup or CUP, that works. No, it doesn't. Okay, setup. Notice how it changes green when you type setup. That's because it's part of the sketch. The sketch functions. There's two. This is the first one you use. Now the setup function only executes one time. Then you put an opening curly bracket, and then it gives you one closing bracket automatically in the next line, and then another line for some reason. And then so the setup is basically a configuration of the different all the pins you're going to be using. So let me use so the first one you want to use is pin mode. Now pin mode is how you configure a pin to either be your input or output, and they do different things. So one thing you can do for extra clarification, it'll be extra bits of data to use, but it'll be worth it because you'll understand what. So one thing you can do is declare a constant. You can name your pins. Yes, you can do that. First thing, there's const. This declares a constant. Int declares an integer variable. Now normally if you just put int or integer there by itself, it's just a variable that's an integer. Basically it's a whole number. Now, but we want it to be a constant, so there. Now let's name it, what shall we name it? Light. Oh yeah, a very creative name. Light. Okay, it's this little one, the orange light. That's by itself. Okay, so one thing to know about pin 13. Okay, 13. Okay, so it's pin 13. Now, one thing you should know about pin 13 is that it's haunted. Not just kidding. No, it's not haunted. There's no such thing as ghosts. One thing to know about pin 13 is that it has its own built-in LED. That's the orange light we have here. So, yeah. So, oh, also, they actually rename it its own. I think, what was it called again? LED pin, was it? Because they updated it and they actually gave it its own name, so it's a constant now. So let's just do it like this, just for the sake of simplicity. Now I'm going to have a button pin that I'm going to put into my Arduino circuit. Integer button. I love Impractical Jokers. Let's assign it to pin 2. Now, here's where the magic starts. Now, let's say we start with pin 13. Pin mode, pin of 13. The 13th pin will be which is the light button, can be configured output. But look at this. Notice how we declared it light. This is what I was talking about when I said the clarification. You can literally just type in the name of the constant that you declared earlier, and it means the same thing, really. Isn't that wonderful? It's more clear now. Now, one thing, you will also have to end your lines with a semicolon. This terminates the line. Now, of course, this is only for a few lines like these. You know, it's declaring variables or constants or variables or even functions. For the beginning of sketches like this part here with the curly brackets, that you don't need a semicolon. Now, the reason light is output is because it's supposed to, the pin 13, aka light, is going to be supplying a voltage, a 5-volt voltage to the LED it's been programmed with. You can also put a LED on it, but that'll be too much. Not that it's gonna be damaging. It's just a bit over flashy. Now, pin mode, button, the button I'm gonna be pressing will be input, because we are sensing a voltage. Now, here's one thing you want to do. Normally, it's gonna be sensing like the slightest change in voltage in the air. Sometimes you'll get a problem called a hot pin. And yes, I've dealt with this too, and it's annoying. Sometimes you'll get a pin that just doesn't want to do what it's supposed to do, and it senses voltage out of everything, even the slightest gust of air, little air, not even, and it's just sensing voltages out of nowhere, not even when it's plugged in. That's called a hot pin. Something happens with the pin itself, and then it no longer acts like a pin, it acts like an antenna. And so it just receives voltages out of nowhere. When that happens, you introduce input pull-up. That makes it more specifically to change when it senses an actual voltage from here. Yeah, I have the right here. And so, okay, so we have the voltage. Now, here's the second part of the sketch. Void loop. Okay, now, void setup runs only once. Void loop repeats. That's why it's called loop. The floor is made out of floor. The floor is made out of floor. So basically, just for giggles, we're not going to use the button right now, but we will soon. Okay, so let's show you what this does. Okay. Digital right. The digital is in all lowercase, but the W is capitalized. Then it turns red. Red means function. Digital right, light, high. Now high can also be 1. Keep in mind we're talking about electronics. Now, just for now, that pin 13 light is going to be on for as long as there's voltage in there. Theoretically forever. For the sake of simplicity, we'll write high. High just means 1, it's the same thing. And then digital right. Oh, for delay. Okay, yeah, delay. Delay pauses the loop for a while. And the argument for delay is a number in milliseconds. So let's make a delay for half a second, which is 500 milliseconds. and then digital right, light, low. Low is also 0. Off. Oh, that, by the way, that bleep bloop, that's my caps lock. I just love the noise it makes. It's really funny. Let's give it a delay of a full second. Digital right, light again. Let's put 1 this time. Digital right. Digital write light. Oh, wait, hold up. Delay. 1500 milliseconds. What, a second and a half. And then digital write light 0 for ah, keep pressing the caps lock for 2 seconds. Yeah. Okay, now there's always this extra line here. I just like to put a comment. Okay, one thing you want to do is you can put a comment. Now this is for if you want a single line comment. Those 2 slashes, comments are ignored by the computer. It's like this is not significant. Basically, the whole point of comments are for like your own little notes. Just for right now, we'll just write this is a comment, a single line comment. Now, if you want to write a comment across multiple lines, you can do this. No, the other way. There we go, and then just hit enter. There we go. Okay, so slash first, and then the pound. These are multiple line comments. Looks a bit excessive, but I'm just a weirdo. So let's program the code into our circuit board. This is the pin 13 we're talking about. This is light. So watch it flash before your eyes. Upload. Compiling sketch. Compiling sketch. Uploading. Done uploading. Done uploading. And there it is. Now notice how it's flashing. It's just going beep. 1 second beep. And then 2 seconds of not being there. Notice how I said high, low, and then 1, 0. They mean the same thing. High is 1, low is 0. You can literally ditch high and low and just write 1 and 0. Now let's make it a little bit more fun. Let's have the delay all be 500, so you can literally ditch high and low and just write 1 and 0. Now let's make it a little bit more fun. Let's have the delay all be 500, so in fact we don't even need this part. Okay, so have it on for 500 milliseconds and then turn it off for 500 milliseconds. See? Okay, so let's upload that sketch and then and then there, you basically just programmed. Yay! This is the simple stuff. There's a lot more to Arduino than just making lights blink. Right now I'm just showing you a light bulb. Well, LED, yeah, not a light bulb. This is just the surface. Okay, so we talked about output. Now let's talk about input. Now this part you do have to know a little bit of the knowledge of logic. Now for this part we have the conditionals. Now basically it's like if this then that. So so now let's first declare a variable. let's call it state. Now notice how I didn't assign a value to this one. You can if you want to. Now state is basically what the switch is going to be saying. We can, when we press this button, it's going to be 1. When we release the button, it's going to be 0. And so state equals digital read button. And so it reads the button, and then here is the if statement. If parentheses state equals put 2 equal signs. 1 equal sign is if you're going to assign a value to a variable. But if you're comparing a variable, use 2 equal signs. These 2 equal signs means is. If a state is 1, oh, no semicolon, open curly bracket, and there, look, you got another curly bracket. If the state is 1, digital write the light pin 1, and then delay, oh no, 500 digital write light 0 and then oh my gosh, my typing is all over the place. I'm sorry. In fact, let's make it go beep beep like that. Yeah, so let's have the loop digital write light 0, and then have it in such a way that if we press the button and it senses that voltage, it goes beep beep, and then else digital write light 0, just like every time. Okay, so there we go. We have the condition for. Okay, so let's go on to building the circuit. Oh, I put it this way. Okay. I keep this one over here so that this eye gets accustomed to the darkness. Wires. Okay. Okay, now this part here, when it comes to building the circuit, you will have to know a little about electronics. Now, thankfully, we're using DC circuitry. DC circuitry is easy. It's rudimentary. It's rudimentary. AC is a little bit more harder, but it can be made simplified if you really know what you're doing. So, okay, so let me get some wires. Here's to. Hey, this one's broken. Okay, these are supply, ground, you're gonna need a big ass resistor. Put it here. Okay. Allow me to introduce you to the switch. It's a button, basically. So, oh, also I forgot to tell you, this is a breadboard. Now, it's a bunch of holes, and inside the holes are these metal tabs. They squish, and they're just like this. You put a pin in there, and it you put a wire in there, and it squeezes over it and holds on tightly. Okay, let me build a circuit. So let's put the button in here. Now the button can be connected to this. I need a red wire. Yeah. Maybe a little unnecessary, but red wire and black wire, using that comparison is easy to remember. So okay, so right, and then there's other colored wires like this one. I have greens, I have yellows, I have purples, and then this one's gonna go in the pin that I've assigned to be the button. Well, the sensor for the button. If you don't know why I'm calling it a button, it's because of Impractical Jokers. Joe is my favorite Joker, and so... Okay, so let's see. I've assigned the button to be pin number 2, so let's put pin number 2 over there. The black one goes in the ground. Don't repeat that. I just realized that's not right. Okay, so... And then the red one goes in the 5. Okay. Okay, so here's a... Here's a nice little test I like to see if the circuit's working. So this side is positive, this side is negative. I'm gonna put this LED in, and it lights up. Okay. Immediately take it out. You're working without resistors. You don't want to fire that LED. Okay. So we now have a working button. Oh, that's the wrong one. We now have a working button. So this voltage supply is going to go here into this part, and then the button is going to go to here, but then when we press the button, it diverts that voltage to this here, this green wire, which is going to go here, but it's also going to go here. This side's going to tell the button pin that this is a negative voltage. No, a negative, no, 0. It's a 0 voltage. Shut up! This is a 0 voltage, telling it that there's nothing, and then once it senses it, it's gonna realize that it's there. Okay, so let's put this in. What just fell? Okay, something fell. Okay, so here we are. We got no voltage going into there. In fact, it's off. Well, it's not the circuit board, because you can see that this is on. The pin 13 is not having any voltage. Now let's press the button. See? Look how it works. See, just like I did my programming, where nothing happens when there's no voltage, and then when you press the button and senses a voltage, it makes that decision, and it does exactly what I did for if that condition becomes true. If true, this, then this, else this. See? And then since this is a loop, it keeps on going. See, so you see how this can be used in like electronic working for like it can be for useful practical applications, such as like say a GPS, or well, actually GPS requires like a receiver in order to receive signals from a satellite. Let's see that you can also be like it can also be used for entertainment, like maybe you want to make an electronic toy or an animatronic. Yeah, if you want to learn to tinker, you want to first like experiment with like little electronic toys and then work your way up to a more bigger projects. Oh, I've turned prepubescent for a moment. So there you have it. That's the basic part of Arduino. In tomorrow's in the next episode, I don't know if it's gonna be tomorrow. I have something to do tomorrow. We're gonna be talking about the difference between analog and digital. So, thank you for watching. Be sure to check out my other videos, like and subscribe. I am Professor Copperstein. End transmission.